Okay. So up today, factoring using a technique called difference of squares. When I say difference, what does that mean? Subtraction. Squares refer to like perfect squares. For example, what's a perfect square? What's a number that's a perfect square?
4.
4, because 4 is what times what?
2 times 2.
Got it. So we're looking for difference of squares here in just a second. I want to kind of work backwards a little bit. I want to see what happens when I take quantity u plus v times another quantity u minus v. So let's just start expanding these out. Take u times u and negative v. What's u times u? Negative v times u is negative u. Now let's go ahead and distribute the v. V times u and v times negative v. U times v is positive uv. What's v times negative v? Negative v squared. Why do they cancel? Isn't that supposed to happen? There's a plus sign here, there's a minus sign here, so shouldn't these two terms be exactly the opposite from each other?
Yeah.
All I have left with is u squared minus v squared. Is this a difference of two squares? Let's check that out first. Is it a difference? Is it one minus the other?
Yeah.
Are u squared and v squared both perfect squares? What times what is u squared? Times v. What times what is v squared? All right. So when I have an expression that reads like u squared minus v squared, one perfect square minus the other, I can factor it. So let's try and factor a couple of these other expressions over here. This side. Can I factor it if it was x squared plus 25? Is that a difference? No, it's adding, not subtracting. I gotta have a minus sign in the middle. So that way, the two middle terms cancel out. I'm left with minus here on the end. So when I factor a difference of two squares, let's write two sets of parentheses. Figure out what's going to go inside of them. So obviously, think about perfect squares. U squared is what in x? You start each of the two sets of parentheses. 25. What times what is 25? 5. One of them has to be negative, one of them has to be positive, right? Because if they weren't different signs, if they weren't positive and negative, would the two middle terms cancel out like they were supposed to here? No. Which is why they have to be difference of two squares. One positive, one negative. So I multiply 5 times negative 5. Makes a negative 25 here, for example. On your own. 16x squared minus 1 is the next one here. What would this factor in? You're going to write two sets of parentheses and see what goes inside. What would I have to multiply that together to make 16x squared minus 1? What are the factors of 16x squared minus 1? Four and 3 is 12. Could be the same two numbers. I think the square root is 16 if you're not sure. Four times 4 is 16. How about 1? What times 1 makes 1? Yep, that one's an easy one. You're going to have two quantities that look pretty much the same. Where? Plus 1. 4x times 4x is 16x squared. 1 times 1 is 1. Yeah, only difference here is the negative sign. Nothing to it. How about 20x squared? With the subtraction sign in the middle. Are 20 and 45 perfect squares? No. No. There's no whole number times itself that makes either 45 or 20. So how are we going to factor this? They're not perfect squares right now. I can't use difference of squares yet. Is there something else I could factor out first? Say again, Ryan? 20 does not divide into 45. It's got to divide into both. I want to factor it out. It's got to be a GCF. 5. John, you said 5. Does 5 divide into 20 and 45? When I write it in fact. 5 times what is 20x squared? Or x squared? 5 times what is 45? I think that's going to be a 9. Look at this. Can I keep factoring 4x squared minus 9? Yeah.
We just had a question about tomorrow's class.
Yeah.
We have the AP exam right after your class, so we were wondering if studying is something.
I'll email you the practice for tomorrow.
Okay, yeah, thank you.
I'll take a video from class and share it with you too. Okay.
Okay, all right, thank you.
You bet. 4x squared minus 9. Is this now a difference of 2 squares? Break down the 5, the GCF I started with. I'm going to break apart 4x squared minus 9 into its 2 factors. Oh, help me out here. 4x squared. What times what makes 4x squared? 2x. I'm going to put a 2x plus and a 2x minus. Now it is it fully factored. 5 times quantity 2x plus 3, quantity 2x minus. Difference there is that you have to factor out a 5 first. There's a GCF that you need to divide it. 9x squared minus y squared. 9x squared minus y squared. Emma, are those 2 perfect squares? What times what makes 9x squared? What about y squared? So let's just factor this. Plus y, 3x. As with everything, how could you check your work? By doing what, Dylan? We've already factored it. If I want to undo the factoring, I would actually just multiply it back together. I multiply this back together and put it back in standard form. Now we got some higher exponents here. 16x to the 4th minus 81 y to the 4th. I think I've still got different.
X squared.
X squared. So my factors right now are 4x squared plus something and 4x squared minus something. How about 81y to the 4th? What do you say, Michael? What times what is 81? What times what makes 81? How about y to the 4th? Y to the second. Y squared times y squared. Y to the 4th. Look at these two factors here. 4x squared plus 9y squared. 4x squared minus 9y squared. I wager one of them is still difference of two squares. Which one though, Eli? Not both of them. Why is it this difference of two squares?
Oh, because it's
Because it's got a plus sign in the middle. This one has a minus sign in the middle. This one's done factoring. This one I can still keep breaking apart. So let's bring down the first, which was 4x squared plus 9y squared. Now we're going to break apart 4x squared minus 9y squared. I'll have a plus sign here and a minus sign here. 2x, I like, for 4x squared. Sense to me. And keep factoring using difference of two squares.